Hello students, welcome to this lecture on statistics. In this lecture, we will cover NCERT section 13.5.4 and example 12 and exercise 13.2 question number 1 to 5. This is disclaimer. First of all, we will cover NCERT section 13.5.4, which is about the shortcut method to find variance and standard deviation. Then we will discuss example 12. Next, we will look at NCERT exercise 13.2 questions 1 to 5. So let's get started. We are going to learn the assumed mean and step deviation method. So this approach helps us simplify calculations, especially when dealing with large numbers or group data. So we will see how using an assumed mean and a common factor can make finding variance much easier. So let's start by understanding why we use the assumed mean and step deviation. When our data values are large or when we are working with continuous distributions, calculations can get messy. Okay, but choosing an assumed mean when we call a and a common factor or class size h, we can make the arithmetic much simpler. So next, we transform our data using the formula yi equal to xi minus a is divided by h. Here h is the class size, a is our assumed mean, and xi is the original data value. Okay, and this transformation gives us a new variable yi, which are easier to work with because they are typically smaller and more manageable. Once we calculate the variance for yi and then convert it back to the variance for xi. Now let's look at the derivation about this method. So we will see how the formulas connect and why this approach works. Okay, so pay close attention to how each step builds on the previous one. We start with two key equations: xi equal to a plus h times yi and x bar is equal to a plus h times y bar. Here xi is any data value, a is the assumed mean, h is the class size, yi is the transform value, and x bar and y bar are the means of x and y respectively. Okay, so these equations show how each original value and its mean relate to the transformed values. Next, let's find the difference between each data value and the mean. So xi minus x bar is equal to h times yi minus y bar. Using this relationship, we can write the sum of square deviations as sum of fi times xi minus x bar whole squared equal to sum of fi times h square times yi minus y bar whole square, and this is simply equal to h square times sum of fi times yi minus y bar whole square. Now to find the variance for xi, we use the formula sigma x square equal to 1 is divided by n times sum of fi into xi minus x bar whole square, where n is the total frequency and this is the standard formula for variance. Now substituting in, we get sigma x squared equal to h square is divided by n times sum of fi times yi minus y bar whole squared. Since sigma y square equal to 1 divided by n times sum of fi times yi minus y bar whole square, here sigma y square is the variance of y and n is the total frequency fi, okay, and fi is the frequency of the ith class, yi is the step deviated value for the ith class, and y bar is the mean of y. Now let's see how this formula changes when we want to find the variance for x instead of y. We get sigma x square equal to h squared is divided by n times sum of fi times yi minus y bar whole square. This is simply equal to h squared times sigma y square. Here h is the class width, and notice that the variance for x is simply h squared times the variance for y. To make it even clearer, we can write sigma x square equal to h square times sigma y square. Now let's take the square root of both sides to move from variance to standard deviation. So we get sigma x equal to h times sigma y. So the standard deviation of x is just h times the standard deviation of y. Recall that the mean of x can be written as x bar equal to a plus h times y bar, and sigma x equal to h times sigma y. So now we have sigma x is equal to h divided by n times square root of n times sum of fi times yi square from I equal to 1 to n minus summation from I equal to 1 to n of fi times yi whole square. Remember, n is the total frequency and yi is the step deviated value for each class. Here is the general formula for variance using the step deviation method. So sigma square equal to h square times summation fi yi square divided by n minus summation fi times yi divided by n whole squared, where yi is xi minus a divided by h, where a is the assumed mean and h is the class width. Now let's take an example. So in this example, we have to calculate the variance and standard deviation for the following continuous distribution. So look at table. So the table shows in first row class intervals like 30 to 40, 40 to 50, 50 to 60, 60 to 70, and so on. And the second row shows the number of data points frequency in each class. Okay, so this question asks us to calculate two things: one, variance, and another, standard deviation for the data set. So first of all, try it yourself. How would you approach this example, and then see the solution. Now let's look at an example. Here we are given a continuous frequency distribution table with class intervals from 30 to 40 and so on up to 90 to 100 and their corresponding frequencies. Our goal is to find the variance and standard deviation for the following data. So let's solve this. So to solve this, we will use the step deviation method, which simplifies calculations when dealing with large numbers or group data. So we will focus on finding the standard deviation using a specific formula. So note here the formula for standard deviation is standard deviation sigma equal to 1 divided by n times square root of n times summation from I equal to 1 to n if I times xi square minus sum from I equal to 1 to n if I times xi whole squared. Here n is the total frequency, if I is the frequency for each class, and xi is the midpoint of each class. Now let's clarify the symbols in the formula. So the a5 represents the frequency for each class interval, and xi is the midpoint for each class. Now n is the sum of all frequencies, which means we add up all the a5 values from the table. For the step deviation method, we choose an assumed mean a, which is usually the midpoint of the class with the highest frequency. So here a is 65 and midpoint of 6. This is basically midpoint of 60 to 70 class. Okay, and h is basically class width is 10 here, since each class interval spans 10 units. Now let's organize our data in the below table. So in this table, you can see in first column we have class interval, okay, and in second column we have their corresponding frequency, and in third column we calculated midpoint xi, okay, and the fourth column we have yi, and here the formula for yi is xi minus 65 divided by 10, okay, and in fifth column we have yi square, and then in sixth column we have a5 times yi, and in seventh column we have fi times yi square, okay. So these values gives us the totals n equal to 50, and sum of fi times yi is minus 15, okay, and sum of fi times yi square is 105. So these values will be used in the next steps to our calculation. So let's see. So we have found sum of fi times yi is minus 15, and the sum of fi times yi square equal to 105, and the total frequency n is 50, and the class width h is 10. Here fi represents the frequency for each class, yi is the deviation of the class mark from the assumed mean, and h is the width of each class interval. So these values will help us plug into the variance formula. So let's recall the formula for variance in a continuous distribution using the step deviation method. The formula is variance sigma squared equal to h squared times summation from summation of fi times yi square divided by n minus summation fi times yi divided by n whole squared. Let's substitute our values into the formula. We get sigma square equal to 10 square times 105 divided by 50 minus 15 upon 50 whole squared, okay. Here 10 is our class width, 105 is the sum of fi times yi square, and minus 15 is the sum of fi times yi, and 50 is the total frequency. Now let's simplify inside the brackets. So 105 divided by 50 is basically 2.1, and minus 5 divided by 50 is minus 0.3. So the equation becomes sigma square equal to 100 times 2.1 minus of minus 0.3 whole square, okay. So here remember we need to square minus 0.3, which will give us a positive value. Next we calculate minus 0.3 whole square, which is 0.09. So we have sigma square equal to 100 times 2.1 minus 0.09, which simplifies to 100 times 2.01, and that equals 201. So this gives us the variance for our data set. So the variance sigma squared is 201. So variance here we obtain 201. And finally, to find the standard deviation, we take the square root of the variance. So sigma equals the square root of 201, which is approximately 14.18. So this is our final answer for the standard deviation. So I hope this example is clear to all of you. So what we have learned in this chapter, okay? So here see, we have discussed mean division, about mean, okay, and the formula is summation from I equal to 1 to n absolute value of xi minus x bar divided by n, okay. It is for ungrouped data formula, and for group data the mean division about mean is summation from I equal to 1 to n of fi times absolute value of xi minus x bar divided by n, okay. And then mean division about median for ungrouped data is summation from I equal to 1 to n absolute value of xi minus m divided by n, okay. And for group data the formula for mean division about median is summation from I equal to 1 to n fi times absolute value of xi minus m divided by n, okay. And variance sigma square for formula for ungrouped data is summation xi minus x bar whole square divided by n, or summation xi square divided by n minus x bar square, okay. And for group data formula is basically summation fi times xi minus x bar whole square divided by n, or summation fi times xi square divided by n minus x bar square, okay. And the formula for standard deviation, that is square root of variance, okay, in ungrouped data and group data both, okay. So standard deviation is basically square root of variance. Now we will start exercise 6.2. so here we will solve question number 1 to 5. So let's see here question number 1. So in this question we will examine a question where we are given a list of numbers 6, 7, 10, 12, 13, 4, 8 and 12, okay. And the question asks us to find the two things. The first thing is the mean, and the second thing is variance for each of the given below data, okay. So first of all, try it yourself and then see the solution. So we need to find both the mean and variance for a given set of data. So let's solve this question step by step. So first, let's see what has been given to us, okay. So here we are given that the data point 6, 7, 10, 12, 13, 4, 8 and 12, okay. Now let's recall the formula for the mean. The mean, often written as x bar, and is calculated by adding up all the data points and dividing by the total number of data points. So that is x bar equal to sum from I equal to 1 to n of xi divided by n. Here xi represents the each data value and n is the total number of values in our data set. Let's substitute our numbers into the formula. So we have each data points. So n equal to n, we have basically 8 data points. So n equal to 8. So adding them up, 6 plus 7 plus 10 plus 12 plus 13 plus 4 plus 8 plus 12, and this is equal to 72. So now divide 72 by 8 to get the mean. So the mean of our data is 9. Next, we will organize our calculation in a table to help us find the variance. So the table has 3 columns. The first column we have the values of xi. In second column we have difference of xi and x bar, okay. And the third column we have xi minus x bar whole squared. where we see a table that helps us calculate the variance. So the columns are xi, xi minus x bar, and xi minus x bar whole square. Okay, and here sum from I equal to 1 to n of xi minus x bar whole square equal to 74. Let's recall the formula for variance. The formula for variance is written as sigma squared is equal to 1 divided by n of sum of xi minus x bar whole squared from I equal to 1 to n. Okay, here n is the total number of data points and x bar is the mean. So let's substitute our values into the formula. So we have 8 data points, so n equal to 8, and our sum of square differences is 74. So variance sigma squared equal to 74 divided by 8, and this is simply equal to 9.25. So our final answer is 9.25. So I hope this question is clear to all of you. So now let's move to the next question. Now let's look at question number 2. So this question is asking, we need to find mean and variance of the first n natural numbers. So students, first of all, think about this. How would you approach this question? So let's solve this question step by step. First, let's focus on how to calculate the mean of the first n natural numbers. So the mean is simply the average value. Okay, and we will see how to find it using a formula. So the mean is calculated as the sum of all observations divided by the number of observations. Since sum of all natural numbers is n times n plus 1 divided by 2. Therefore, mean becomes n times n plus 1 divided by 2 divided by n. Okay, this is simply n plus 1 divided by 2. So our average of first n natural numbers is always n plus 1 divided by 2. Now let's move on to the variance. The variance is written as sigma squared is equal to 1 divided by n times sum of xi minus x bar whole squared from I equal to 1 to n. Now let's substitute the value of mean x bar. Okay, and we get variance equal to 1 divided by n times sum from I equal to 1 to n of xi minus n plus 1 by 2 whole squared. Okay, so this means we subtract the mean from each number, square the result, and then 1 up and then divide by n. Now let's start by writing the formula for variance for a set of numbers x1, x2 up to xn. The variance sigma square is given by 1 divided by n summation from I equal to 1 to n xi square minus 1 divided by n times summation from I equal to 1 to n of 2 times n plus 1 by 2 times xi plus 1 divided by n summation from I equal to 1 to n of n plus 1 by 2 whole square. And we know summation from I equal to 1 to n xi square equal to n times n plus 1 times 2n plus 1 divided by 6, where summation from I equal to 1 to n xi is n times n plus 1 divided by 2. Therefore, variance sigma square equal to 1 divided by n times n plus 1 times 2n plus 1 divided by 6 minus n plus 1 divided by n times n plus 1 divided by 2 plus n plus 1 whole square divided by 4 times n times n. Now let's simplify this. So after simplifying, the variance becomes sigma square equal to n plus 1 times 1 plus 1 divided by 6 minus n plus 1 whole square divided by 2 plus n plus 1 whole square divided by 4. Let's combine the last two terms. we get sigma square equal to n plus 1 times 2 n plus 1 divided by 6 minus n plus 1 whole square divided by 4. Therefore, variance equal to n plus 1 times 4n plus 2 minus 3n minus 3 divided by 12. And after simplifying, we get variance equal to n plus 1 times n minus 1 divided by 12. And this is simply equal to n square minus 1 divided by 12. Therefore, variance sigma square equal to n square minus 1 divided by 12. So I hope this question is clear to all of you. Now, let's look at question number 3. So, we have to find the mean and variance of the first 10 multiples of 3. So, first of all, try it yourself and then see solution. So, the questions ask us to find the mean and variance of the first 10 multiples of 3. So, we will solve this question step by step. So, first, let's list the data we are working with. The first 10 multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. So, these are the numbers we will use to calculate both the mean and the variance. So, we know x bar equal to summation from I equal to 1 to n xi divided by n, where xi are data points and n is the total number of data points. So, here number of observations n equal to 10. So, n equal to 10. So, mean x bar equal to summation from I equal to 1 to 10 xi divided by 10 is equal to 165 divided by 10, and this is simply equal to 16.5. Now, let's see our following table. So, in this table, in first column we have the values of xi, in second column we have xi minus x bar whole square, xi minus x bar, and in third column we have xi minus x bar whole square values. Okay, so very carefully calculate all these values and then use these values to find the variance. So, here we see a table that helps us calculate the variance. So, we know variance sigma square equal to 1 divided by n summation from I equal to 1 to n xi minus x bar whole squared. So, now substituting our values into the formula. So, we have variance sigma square equal to 1 divided by 10 of summation from I equal to 1 to 10 of xi minus x bar whole square. This is simply equal to 1 by 10 times 742.5 equal to 74.25. Therefore, the variance for our data is 74.25, and this is our final answer. So, I hope this question is clear to all of you. So, now let's move to the next question. Now, look at question number 4. So, the question asks us to find the mean and variance for each the given below data. So, first of all, try it yourself and then see the solution. So, we need to find the mean and the variance for a set of data. So, the data is given in a table with two rows. First row xi, which represents the data values, and the second row fi represents the frequencies of the given data. So, our goal is to use this table to calculate the mean and variance step by step. So, look at here this table. In this table here we added the third column. Here we calculated fi times xi. Here n is summation from I equal to 1 to 7, fi is equal to 40, and summation from I equal to 1 to 7, if I times xi is 760. And we know that mean x bar equal to summation from I equal to 1 to n, fi times xi divided by n. Therefore, x bar equal to summation from I equal to 1 to 7, if I times xi divided by n, this is equal to 760 divided by 40, and this is simply 19. Now, we will add 3 new columns, xi minus x bar, xi minus x bar whole square, if I times xi minus x bar whole square, where x bar is 19. So, the new table will be look like this. Okay, so here we calculated xi minus x bar, xi minus x bar whole square, and fi times xi minus x bar whole square. So, here n is summation from I equal to 7, I equal to 1 to 7, a5 is 40 and summation I equal to 1 to 7 a5 times xi minus x bar whole square equal to 1736. So we know that variance sigma square equal to 1 divided by n summation from I equal to 1 to n a5 times xi minus x bar whole square. Variance sigma square equal to 1 divided by n summation from I equal to 1 to 7 a5 times xi minus x bar whole square equal to 1 by 40 times 1736 equal to 43.4. Therefore, the variance sigma squared equal to 43.4 and the mean x bar equal to 19. So these are our final answer. I hope this question is clear to all of you. So now let's move to the next question. Now let's examine our frequency distribution table where we have values of xi and if I. So we have to find the mean and the variance for each of the given below data. So let's see how to solve this question. So we will solve this question step by step. So let's see. So first of all, we organize the data into a table with 3 columns. First column xi, second column fi, and third column fi times xi. Okay. And from table here n equal to summation from I equal to 1 to 7 if I equal to 22 and summation from I equal to 1 to 7 if I times xi is 2200. We know that x bar equal to 1 divided by n summation from I equal to 1 to n if I into xi. Therefore, x bar equal to 1 by 22 summation from I equal to 1 to 7 if I times xi is equal to 1 by 22 times 2200 and this is simply equal to 100. Now we will add column xi minus x bar whole square fi times xi minus x bar whole square where x bar is 100. So the new table will be look like this. Okay, so we calculated here xi minus x bar whole square and fi times xi minus x bar whole square. Okay, and here in the bottom of the table we have total summation fi is 22, summation fi xi is 2200 and summation fi times xi minus x bar whole square is equal to 640. And we know that variance sigma square equal to 1 divided by n times summation from I equal to 1 to n fi times xi minus x bar whole square. Therefore, variance sigma squared equal to 1 divided by n summation from I equal to 1 to 7 fi times xi minus x bar whole square. And here we substitute the value of n is 22 and summation from I equal to 1 to n fi times xi minus x bar whole square is 640. So variance sigma square equal to 1 by 22 times 640 and this is simply equal to 29.09. Hence the variance is 29.09 and mean x bar is 100. So I hope all the questions are clear to all of you. So that's all for today's lecture. Thank you very much to all of you. I hope this lesson was helpful to all of you.